So, if you've never heard of version control before, version control is basically really fancy record keeping on all of your changes that you make to a bunch of files in a directory. You can sort of think of it like whenever you make changes, you do a bunch of stuff, and then you say, I'm happy with this set of changes. Then you pick out all of them, put them in a log, and you commit them, which means that you can roll them back so you have your older files still, but those changes will be preserved forever and you can't accidentally lose them. Version control is really important for large projects especially, because if someone introduces a change to your project that causes things to break, you can find out what change did it really easily, and you can undo that change even easier. So those are two really important aspects of version control. Also, if you've used Dropbox for projects before, that's a bad idea, because Dropbox doesn't keep a full history of your files, and it's not easy to roll them back. Additionally, Dropbox doesn't let you make branches and different areas where you can work on other parts of your project simultaneously with other people. These are all features of Git and a bunch of other source control systems. We prefer to use Git because it's distributed and an industry standard. It is made by awesome people. Literally every software company in the world uses Git somewhere. And a great place to use Git, if you don't want to host your own servers for it, is GitHub, which is this super awesome site that I'm already logged into. But you can go to GitHub and you can make a bunch of repositories that you can share with other people, and then you don't even have to be remotely in the same place. You can all work on the same set of files and make changes to them and update them and stuff. So it's really helpful. GitHub is also free. And if you're a student, it's not just free, it's also free to make private repositories that not everyone can see. So we suggest GitHub is really good. There are also a bunch of alternatives. Pick whichever one you guys are most happy with. So get that installed, and we'll start in like 4 or 5 minutes. Anyway, now, does anyone not have Git installed? Does anyone not have Git installed who wants to get it installed? Okay. Go quick, and we'll catch you up really soon after. So the first thing that we're going to do is make a repository that we can all work from. This is where GitHub comes in. You can think of GitHub as the place where you actually put your files. So it's sort of like the Dropbox for your repository, but instead of it being sort of like a single static, here are the files that everyone has up to date, it has a full history of all the files, and not everyone needs to be on the exact same revision of all the files at the same time. But what we're going to want to do is make a repository. So from GitHub, if you've logged in or signed up, you can just click New Repository, and then we'll name this some repository. So you give it a name and a description. You can choose public or private. We'll leave it public for now. You can also initialize it with a README if you want, and you can add git ignores. Both of these are important. Basically, a README will show up on your projects page, and it'll make it really easy to tell people a little bit about your repository when they first visit it. Git ignores tell Git what files should be kept track of and which ones they should ignore. So when you have a game and you build an executable for something, that's something that you don't want to check into GitHub. You don't want to commit it using Git and then push it. And that's because even though you built an executable for it, everyone should be able to build their own executable for it. Common exceptions are if you make final builds, like if you have an alpha build or a beta build or a final release build, that's something that you'll probably want to check in, have it for posterity. So git ignores sort of come on a per project basis, but there's a whole bunch of them in here. And just as an example, we'll use a Unity git ignore. which is tailored just for Unity projects and will make it so you don't push the stuff that Unity makes that's temporary files and are regenerated all the time anyway. You can also pick a license. If you leave it at none, it'll just be copyrighted by you, which is totally fine. Just understand that if it's a public repository, it doesn't really matter whether or not you claim to have copyright on it. People will steal your code. Picking one of these licenses is probably a better idea if you want to share your code with other people. You can look up more about licenses other places, but we'll just leave it at we'll MIT license it. That's pretty good. And you just click Create Repository. So now you've already got one set up. You're ready to what we call clone this repository. So here's where some of the philosophy of Git comes in. Your repository on GitHub or on your Git server is sort of like the authoritative central location for all of your stuff. But when you make changes, you make them on your local repository. And your local repository is basically an exact duplicate of the one that's on the server. So when you want to make changes to the one on the server, what you do is you make changes locally, get them all finished up, and then you push them to the server all at once. So when you edit a file, it'll stay a local change until you're ready to commit a bunch of them together. This is especially useful for when you want to make when you want to add a new feature, for example, like, oh, I want to add moving platforms to my platforming game. You can make one commit that adds moving platforms that changes a bunch of files and push that in one go all the way up to your central server repository. Then everyone else who's working on the project can pull it down without running the risk of getting your commit halfway through when you're still working out some bugs or you're in the middle of some changes and the project won't compile right now because they're not fixed yet. So the goal is to make it so everything that you push to your repository on the server is code that will work. And when people pull it down, it won't stop them from doing their job. It'll just make sure that they get your feature and nothing else will break. Yes. So we'll talk about branches a little bit later, but branches are sort of like taking your repository and going off to work on something else for a little bit. Commits are good if you have a change that you want to make in exactly one commit. If it's going to take multiple commits to get something up to speed, like you're adding a really big system, for example, if you're adding a large UI system, you'll probably want to spread that out over multiple commits so that you don't lose your work or risk losing your work along the way. So you might go in stages like added dialog boxes, added buttons, added reconfigurable text, and so you'll probably end up with a bunch of commits. In that case, what you want to do is make a branch for them, and on that branch, put all your commits, and then later, once that feature is completely done, you'll merge it back in. And that's basically just doing all of the work of pushing your commits to your GitHub repo all at once, instead of in pieces. So you do all the work, and then you merge it all at once. We'll talk more about that later. For now, we'll just hit the ground running. We've got this super awesome project with a git ignore, a license, and a README, and our README shows up here. So now we're going to clone it. So what you're going to want to do is look for git, which will probably be git bash or git cmd. One of these will work. Yeah. So with your git bash, you're going to need to make a folder for your repository. So find somewhere that you're comfortable making a folder to clone all your code down. If you're not familiar with command line, we'll do like probably 2 commands. We'll just make it in our documents. So cd means change directory, and then we'll just cd into documents, which means we're going to go into our documents directory from our command line. Documents. And now that we're in here, we can clone our repository, which luckily is super easy. All we have to do is git clone, and then the URL up here. If you want to make changes to this repository, you're more than welcome. All you have to do is tell me your GitHub username, and we'll do that in a little bit. So now we've done this git clone, so let's look at what this said line by line. We've cloned into Git Workshop, which means that we've taken all the code on the server and we've cloned it into a file, into a folder called Git Workshop. Then it says remote, counting objects, 5 done. That means that we've counted 5 things that we've made, and then it's compressed all of them, and then it sent them to us, and then it unpacked them, and then it checked everything, and we're good. So basically, we didn't get any errors. All of our stuff will be there. And now, if we cd into Git Workshop, we can see that we have our license and our README, and our git ignore doesn't show up unless we do that. Ooh, I think it's A. Yeah. So we've got a secret Git folder here, which is hidden, and no one will see it unless you're looking for it. We've got our git ignore, our license, and our README. So we've got our 3 files pulled down. We're all set to go. Now we want to make a change. So let's make a new file and just put some text in it. If we go to our documents, we can actually find this exact folder. I think I can just do that. Yeah. So if we go into our documents, we can see there's our Git Workshop folder that we cloned into, and there are 3 files. So let's just make a new one, call it testing. Then we can open up that and put some stuff in it. And then we save it, and now we've got a change that we're ready to push back to our repo. This is going to come in 3 big stages, which are going to be staging, committing, and pushing. So for staging, your command is add. You're going to type git add, and then you're going to tell it what files to add. If you want to add all your files, you can do -A. That. So now we've added all of our files that have changed. If we want to check them, we can just type git status. And it'll tell us that we're adding a new file called testing.txt. So these are all the changes that we have staged right now. These are ready to go into one commit to our repository. Once we've made sure that all of those changes are the ones that we want, we can commit them by saying git commit, and then -m will give you a message that you put along with your commit. So we'll say added testing file. And then it'll complain that you haven't configured everything. So these are pretty easy. You sort of just follow instructions. Global edit. So right now what we're doing is we typed in the command that it told us to. We just need to give it our username and our email. So I know I can't make it bigger. Can I make it bigger? See if we can make text bigger. That big. That's too big. What's everyone's favorite font size? Let's try 24. 11 is also my favorite font size, I'm not gonna lie. Okay, so now we can edit this and say our name, we will be me, even though it's Ryan. Sorry, Ryan. So in your name spot, you're actually going to put your real name. And then your email, you're going to put your email. Like that. These are only important because these get sent along with your commit. So when people say, hey, who made this change to my repository? They can say, oh, it was David that made that change. You got it. So this is part of the cool stuff about Git. So once we make changes to our repository, every single change that we make, we know who made it, when they made it, and where they pushed it to. So when we do want to know, hey, who added this code that makes it so it changes our player to null every single time that I press the spacebar, I don't want this code, we can say, who did that? And Git will tell us, oh, David did it in this commit on this date with this message. And then you can go yell at them and say, why'd you do that? And they'll say, just testing your Git knowledge. OK. So now we've edited that. We can do our commit now. Let's already did it. OK. Our commit is already good. When we do get status, it'll tell us what branch we're on, which is master, which is good. That's where we want to be. And it'll say that we are ahead of origin master by 1 commit. This means that we've done 1 commit on our local machine that we haven't pushed yet. So let's push that. And it'll ask us to log in to our GitHub. And then it will push it. And it will yell at us if there are any problems. But we're probably good. So now we've gone through our stages. Git add is our staging. Git commit makes our commit. And git push pushes it to the server. Those are the 3 basic commands that you need to know. And now when we refresh, we can see there are 2 commits. We can see added testing file. We can see what change they made, and when they did it, and who did it. And we can comment on it if we don't like it. So this is super cool. That's the basics of version control with Git. You really don't need to know much more than that until you start having problems, which are stuff is broken or you don't know what to do because you messed up your Git and now it's broken forever. Please help. That's the sort of thing where you just Google what problem you're having and you will almost always find the solution. So if everyone else wants to try pushing to this repository, just give me your GitHub usernames and I'll add you to it so that you can clone it and make your own commits and push them. So go make a GitHub if you want to do it. OK. So I don't know if anyone else wants to collaborate on this besides Leah, but like totally give me your GitHub username and I'll add you to this repo. All it'll do is make it so that you can get this repo and you can make changes to it and commit them. So you can add your favorite really bad meme if you want, or you can push some quality OC, basically whatever you want. So if you want to get in on the GitHub action, give me your GitHub username. Your GitHub username is right here in front of whatever repository you made. If you click on here, it'll say signed in as whoever. That's your GitHub username. What was that? That one? Added. So now you can use git clone, and you can do git clone this. And when you do, you'll be able to make changes, commit them, and push them just as you normally did. Anyone else want to get in on the action? Please, I need participation. Volunteers? This is kind of making me sad, but whatever. I guess Jordan and I will do this, and Leah. OK, so Max, what was that? OK, what's your GitHub username, Max? I'm just guessing. No, it's not that one. Oh, I found you. You're MSI K314. Like MIROR, that one? Added. OK, so now that you all have access, what you want to do is start cloning stuff. You can clone the repo just like you did normally. cd ... goes up a directory. So instead of being in documents Git workshop, I'm back in documents now. So I can do the same thing that I did at the start. Git clone, github.com, me, git workshop, ooh, like that. Yes, so if you click on this, it will tell you what link you should put in there. Hey, what? You don't know what? Are you sure? How sure are you? You didn't accept the invite yet. Are you sure? Okay. Because we're going to reclone it, I'm just going to nuke my local copy. Because you can sort of see, I've already got a Git workshop in here. So let's remove that. This is the command to remove stuff when you're on like Linux-like command lines. RM means remove, R means recursive. If I remove a folder, I want to remove everything in it too. And then F means I mean it, don't ask me any questions. If you leave off the F, it will ask you every time that it removes a file. F means I'm definitely sure. And now it's gone. So we can clone it again. So it's cloned. We're all good to go again. It's back in here, right there. You can CD into the Git workshop. And all of our files are still there, which is something else nice about GitHub. If you accidentally nuke your repository or your hard drive dies, which is bad, they're all still there because all of your code is on the server, and even in that case, everyone else on your team has their own local copy of the code. So it's very good at stopping bad things from happening. So we're back in here. We want to make some more changes. So let's like if we type status, it'll show up in red, this new file that we made. That means that we haven't told it that we want to make it part of a commit yet. We just added it, so now if we check our status again, it's green because it'll be part of our commit. We can commit it and push. We're up to 4 commits. It seems like someone has added a quality memes folder. So we can look for that quality memes folder by using Git Pull, which says all of the changes that are on the repository that someone else made, I want those too. Oh, it looks like I already have them actually. Okay, so there's my quality memes folder. Let's go check out what's in quality memes. Topnotch.jpg. So someone else made changes. Specifically, Leah made changes. Which we can see if we go to our commit history and we check out quality memes. And we can see exactly what she changed, when she changed it, and for files like JPEGs or other stuff, it'll preview it for us instead of giving us just a giant dump of what the actual data for this JPEG is. So Leah added this picture, and we can see I added this file. So more people do stuff, and then we'll check out who did what. Okay. Okay, who wanted to add over there? What's your name? Yeah. Ian dash what? Oh, okay. Gotcha. Okay. Let's see if any more commits happen. So people will make commits now. The nice thing is I don't have to do anything locally. And as long as I don't do anything, my repository will stay the exact same way as when I left it. So in Dropbox, there's a huge problem where you're all working on a project together and someone changes a file, suddenly everyone gets that change instantly, even if that change was bad and broke your whole project. And suddenly no one can work on it until that is fixed. With Git, you're in control of when you get other people's changes. So that's a really good way to make sure that everyone can keep working no matter what's going on. Okay, so now we're at 5 commits. So let's pull a commit. Git pull, as normally. That's all we have to type. It'll go find out what changed. And then here's the important part. Wherever you see this red and green text, it'll tell us what got added. Specifically, this quality memes git memes.jpg. So now we can go find out what exactly was in there. There we go. So any changes that other people make, I can pull locally. But let's say that something happened with a change that I don't want. So for example, if I want to know who added this low quality meme to the quality memes folder, specifically, let's check top notch. Top notch is not high quality enough, let's say. So we have this super cool thing called Git Blame. It'll give us a bunch of things that we can do with it. So all we do is git blame some stuff and then whatever file. So here we can type git blame top notch. Mostly garbage, but you can see that some of these commits are from Liam McGrain. So we caught her red-handed. Did you make changes, Ryan? Okay, so Ryan made some changes. Let's pull those. So Ryan made information.txt and snipsnap.jpg. Oh, okay. So someone else made information. So let's actually go edit that one. Let's see what's in information. So let's say that we add some information to it. So we can save it and push it. And push it. Okay, Ryan wants us to look at his meme now. I'm having a meme off, apparently. So Ryan has provided us a wonderful meme through the power of Git. So that's how easy it is, really, to work with GitHub. You can even have multiple people working on the same file. That's when you'll start learning about merging. So Ryan and I will edit the same file at the same time, and then we'll compete with each other to see who can make it the worst. Let's both edit the... What one are you editing, Ryan? Okay. So we'll both edit information.txt. So this is like worst case scenario. Ryan and I have edited the same file. How are we going to be able to put them back together even though we both made different changes? Okay, so we'll wait until Ryan makes his change, and then we'll pull it down. So when we do, the copy of the repo that's on GitHub has a different version of the information.txt than we do locally. We have a change that the server has also, we have a file that we've changed, and so has the server, which means that we're going to be in charge of a merge. So if we pull, we'll see conflict right here, and it says merge conflict in resources information.txt. Because Ryan's edited it, and I've edited it. Luckily, this is pretty easy to resolve most of the time. So what happens is Git will have a head, and then a bunch of equals, and then something else. This head part is your copy of your changes. After the equals is their copy of their changes. And then this means this is the end of the conflict. So Git is really smart about this. If two people edit the same file, all you have to do is figure out how to put these two changes together, and then you'll be good. So we can get rid of this. We just want to keep both of them. Make it, well, maybe we'll make it like 421 instead. Because some time has passed. Okay, so now we've merged our changes together, and this is what we want our file to look like. So now, because our pull failed, we're in the middle of a commit. We didn't stage anything yet, but we're in the middle of a commit right now. If we type git status, we'll see that there are some changes. Specifically, we got dsstore, which Ryan's Mac made, and he pushed. But we've also got this both modified resources information.txt. So we want to add that, and then we want to commit it. This time, instead of providing a message, if we just type git commit and hit enter, it'll generate a merge commit for us. So this says merge branch master of yada yada yada. This basically says there was some branch on the server that we pulled down, and we had conflicts, so we merged them. So we make sure that this all looks good. That's our commit, and now we can push. And now if we go back to our GitHub, we're already up to 13 commits. Our information.txt is the way we want it. And we can see all the commits that happened, from the initial all the way up to here. So let's say that something bad happened with this merge that I did, which will almost always happen if you don't double check yourself. So let's say I did this merge and I was like, it wasn't supposed to change to be 421, it was supposed to stay the way it was. I want to roll back whatever change I made. So I can look here and say, what I really want is this commit. So this commit has a hash, which is this little 7-digit number in hex in front of there. And now what I want to do is I want to check out that commit, which means I want to take the current state of my repository and I want to go all the way back to that commit. I can do this with git checkout and then put in the name of the commit. So this will put me in a detached head state, which I can get rid of later. But basically, I've rolled back to that commit. If I type git status, nothing to commit, but if I go check out my file, this is before the change that Ryan made got pushed. So now I can get back all my files if I accidentally make a change that I didn't want to do, or someone else did, which is always the case. You know, everyone is flawless, and everyone else's changes are the things that break it. Now to get back, what we want to do is get back to our current commit, which we'll do with git reset right there. I'm going to have to do a different git, right? Okay. So we can check out the current commit, but that might still make us detached. Can I? Okay, yeah, actually. Okay. So git checkout master will get us back to the current day. Oh, not status. Okay. And now we're back, and if we check out our file again, we'll look at our file again. We're back to the future that we came from. So with Git, we can go backwards and forwards in time, which is super good. And now we'll try git blame on it, because that's what we wanted to do in the first place. So each of these will tell us who changed it last and when they changed it. So you can sort of see these first two lines have their own separate commits. And this next few lines have different ones. So this commit, if we go back to our GitHub, we can go to our commits. We can say, where is C653 something, something, something. We can see this was the commit that added this line, and then this was the commit that added that one, and these ones made those ones.
The cool thing is, even if a line gets moved to a different file, it will still track it properly.
Yeah, so if you like take a file and say move some of the code somewhere else, Git will know that, and it will still track your line-by-line changes properly. So this is some of the cool stuff that you can do with Git. For most of you, it will be perfectly all right to just know git clone, git add, commit, push, and pull. The more complicated stuff with git checkout and git reset and all that stuff, that's only in the case of when you've made some changes and stuff is broken now, and now you're in emergency mode, and you need to get back to some previous version of a file. So that's your Git basics. You should use this when you're working on your project, because this is the way that it's done in the industry, and it'll make sure that when you make changes, you're not going to break everyone's stuff, and if you do, you can always revert those changes. So I guess any questions about Git, or is everyone asleep already? Cool. All right, well, that's all. Yeah, okay, well, we'll make a Unity project in here just to show you how to get Unity set up with your GitHub. So you might remember earlier that we told it that we want a Unity git ignore, and that's important because Unity generates a bunch of temp files that we don't want to push to GitHub. We just want to keep them locally. We want Git to ignore them, so we put them in our git ignore file. We fire up Unity, and then make a new project and say we want to put it in our Git workshop folder, and we'll name it Amazing Project. Unity will go ahead and make a project in here. And we can go look at it and say, there's our project. So importantly, just as a quick overview, the things that you do want to push are your project settings and your assets. Your temp and your library, you don't want to push. Unity will regenerate those automatically. You don't even have to worry about them. So this is where our git ignore is going to come in. This git ignore is for Unity. All you have to do is make sure that the git ignore is at the root of your Unity project alongside your assets, your project settings, your temp folder, and all that stuff. So let's just save a quick scene here, just to add some asset. So we saved the scene, and now we can see that we moved our git ignore, and we added this big folder of amazing project. We're almost ready to start moving our stuff from Unity into Git, but there are a few settings that we have to mess with. These are things that you should always do before you start using Unity with Git. You're going to want to go to Edit, Project Settings, Editor. And here you've got two things that you want to change. You want to change your version control mode to visible metafiles. That'll make it so Git can pick up your .meta files a lot easier, which you do need to push to GitHub. And then under asset serialization, you want to set your mode to force text instead of mixed or binary. The difference between those are when you have assets in Unity, it'll serialize them as some weird, hard to merge format, unless it's set to force text. Even though you shouldn't be merging assets most of the time, if you do have to, it is possible when they're text serialized, and basically impossible if they're mixed or binary. So those two settings you want to make sure that you have. So now let's add this. If we check it, we've got all these new things here. We've got some asset stuff and some project setting stuff. These are all good, so let's just commit those. And now if we check GitHub again, we've got our amazing project on here, which is exactly what we want. Everyone else who's working on this project can use the Unity project the exact same way. Just make sure that you have your git ignore and those two settings, which are visible meta files and force text for serialization. That'll make it so Unity and GitHub get along really, really, really well. So any questions before we wrap up the workshop? It can be about anything. Okay, that's all then. If you have any other questions, feel free to ask us. What I would suggest doing is before you leave, make a GitHub for your group and make sure everyone can work on it and get your Unity project set up. Because once you're past that stage, you can all work pretty easily together. And if you do it here, we'll be able to help you if you accidentally mess things up, which happens pretty much inevitably. So yeah, by all means, ask us for help if you need it, but try getting a repository set up for your project. That's all.